In this video, we're going to solve more complicated exponential and logarithmic equations. So we have 4 to the 3x minus 1 equals 3 to the power of 2 minus x. Now they have different base. So you cannot just say that 3x minus 1 equals 2 minus x, since they have different base. This wouldn't work. So what we need to do is we need to do natural log both sides. So again, using the power property, quantity 3x minus 1 goes before natural log, and quantity 2 minus x goes before natural log of 3. Now, what we need to do is we need to distribute natural log of 4 here. So you get 3 times natural log of 4 times x minus natural log of 4. I just distributed the natural log of 4. Now I'm going to distribute natural log of 3 over here. So you get 2 natural log of 3 minus natural log of 3 times x. Now what we need to do is we need to put the x's together. So I'm going to add positive natural log of 3x to both sides. You're going to get 3 natural log of 4x plus natural log of 3x. And then I'm going to add natural log of 4 to both sides. So you get 2 natural log of 3 plus natural log of 4. Now what I'm going to do is I'm going to factor out x over here. So you end up getting x times the quantity 3 natural log of 4 plus natural log of 3 equals 2 natural log of 3 plus natural log of 4. Now, how do we have x by itself? We need to divide both sides by 3 natural log of 4 plus natural log of 3. So you end up getting x equals 2 natural log of 3 plus natural log of 4 all over 3 natural log of 4 plus natural log of 3. Now we're not done yet because we could simplify this. Using the properties of natural log, that becomes the exponent, so you get natural log of 3 squared, which is natural log of 9, over 3 becomes exponent, so you end up getting natural log of 4 to the third power, which is 64, plus natural log of 3. And notice, we could use the product property. Since we're adding 2 natural log, we can multiply 9 times 4. You get natural log of 36 over natural log of 64 times 3, which is 192. So this is your final answer without the calculator. So if you use your calculator, you're going to get approximately 0.68. So that will be the solution to this exponential equation. Now we did it algebraically. There's a way of solving this graphically. In order to solve graphically, what you need to do is you need to graph these two separately on the same screen and then see where they intersect. So I have y equals 4 to the 3x minus 1 and y equals 3 to the 2 minus x. So I have both of these graphs and see where they intersect. Look at the x value. It says approximately 0.682. And that is the value that we got by solving algebraically. So you can see that the solution is the x value of the point where these two equations intersect. Now let's solve e to the 2x plus 6 e to the x minus 16 equals 0. In order to solve this, let's review solving x squared plus 6x minus 16 equals 0. How do you solve this? Well, is this factorable? Yes, it is. Quantity x plus 8 times quantity x minus 2. So this will be x plus 8 equals 0, or x minus 2 equals 0. Therefore, you get x equals negative 8, or x equals positive 2. Now, we're going to use a similar method here. I'm going to rewrite this as e to the x quantity square. Notice, this is the same thing as e to the 2x, plus 6 e to the x minus 16 equals 0. Now notice, this kind of looks like this quadratic equation over here. If you let x equals e to the x, this is very similar to this. So what we're going to do is we're going to factor this. So you get quantity e to the x plus 8 times quantity e to the x minus 2 equals 0. You might want to pause the video and see why when you factor this, you get these two factors. So now you're going to get e to the x plus 8 equals 0, or e to the x minus 2 equals 0. So you get e to the x equals negative 8. Now how do you solve for x? Well, you got to do natural log both sides. So you end up getting x equals natural log of negative 8. But wait, you're not supposed to have a negative number inside natural log. It has to be positive. So this does not exist. If you plug that into your calculator, it's going to give you an error. So this doesn't exist. It's not a real number. What about that one? E to the x equals 2. So you get your natural log both sides to solve for x. You end up getting x equals natural log of 2, which is approximately 0.69. So you only have one solution, which is natural log of 2. So graphically, what does it mean? When you graph this and then try to find the y value that is equal to 0 or the x-intercept, the same thing. The graph will go through the x-axis at approximately 0.69. So we have a graph of e to the x plus 6 e to the x minus 16 over here. And when is this equal to 0? Well, that equals to 0 when the y value is equal to 0, which is the x-intercept. And where is the x-intercept? It's approximately at 0.693, 0. So that was the answer that we got, which was the natural log of 2. Now we're going to solve this equation. In order to solve this, what we're going to do is we're going to use the property of natural log first. So this is addition of natural log. So what we could do is we could multiply x plus 2 and 3x minus 2. What about 2 in front of natural log? That becomes exponent, so we could rewrite this as natural log of quantity 2x to the second power. Now this is natural log, that's not natural log. So what you could do is you could exponentiate both sides. So you're going to get quantity x plus 2 times 3x minus 2 equals quantity 2x squared. Now we just need to solve for x. So let's multiply this. You're going to get 3x squared plus minus 2x plus 6x minus 4 equals 4x squared. And then you get 3x squared, combine the like terms, plus 4x minus 4 equals 4x squared. And you'll end up getting, let's move 4x squared to the other side. You get negative x squared plus 4x minus 4 equals 0. I don't like that negative in front of x squared, so I'm going to multiply everything by negative. You could do that because this is an equation. So you get x squared minus 4x plus 4 equals 0. So when you factor it, you get x minus 2 equals 0. So you just have x equals 2. Now make sure you double check. Plug in 2 and see if you get the same numbers on both sides. When you plug in 2 here, what do you get? You get natural log of 2 plus 2, which is natural log of 4. What about over here? 3 times 2 is 6. 6 minus 2 is 4. So plus natural log of 4. Is that equal to 2 natural log of 2 times 2, which is 4? Well, you know that that's going to be natural log of 16. When you add natural log, you got to multiply 4 times 4. And 2 is 2, you can move, it becomes an exponent, so you get natural log of 16 as well. So that is the solution. And of course, if you graph this, where do you think they're going to intersect? At which point? We know that the intersection point will have an x value of 2. And let's take a look at our last example. So in order to solve this equation, you got log base 12, you're adding. So what you could do is you can multiply 12x with x minus 1. So log base 12, 12x times x minus 1 using the product property. That should equal to 2. Now, in order to solve for x, what we're going to do is we're going to change to exponential form. So base is 12, exponent is 2. That should equal to 12x times x minus 1. Now all we got to do is solve for x. So 12 squared is 144 equals 12x squared minus 12x. So this will be 0 equals 12x squared minus 12x minus 144. And let's divide everything by 12. You could do that because this is an equation and 12 goes into all of them. So you get 0 equals x squared minus x minus 12. Let's factor it. X minus 4, x plus 3. So you get x equals 4 or x equals negative 3. Now, make sure be careful. You need to make sure that both of these two work so that they're both solutions. Let's check x equals 4. You get log of 12. 4 times 12 is 48 plus log of 12. 4 minus 1 is 3. Is that equal to 2? Well, let's see. You're adding, so you could multiply 48 and 3. So log base 12. 48 times 3 is 144. So log base 12, 144, is that equal to 2? Well, this is the same thing as 12 to the second power equals 144, right? Is this true? Yeah. 144 is equal to 144. So we know that x equals 4 is a solution. What about x equals negative 3? When you plug in negative 3 over here, right, what do you get? You get negative 36. And you cannot have a negative number inside log. It has to be positive. So you automatically know that that is an extraneous solution. So we only have one solution, x equals 4. Oh, and of course, when you graph this, when you graph these two, they're going to intersect when x equals 4.